So, good morning. My name is Mark Major. I'm the Senior Strategy Director for the Kuehne Climate Center, and it's my pleasure to welcome you today to this webinar on the future of refrigerated maritime transport. We've got people registered from more than 20 countries for the webinar this morning, which will take a little bit more than an hour. We plan to be done by 10:15, so just over 80 minutes. The webinar will be recorded this morning, but we were just recording the presentation, not the faces of people involved, but you should be aware of that. We will also share the presentation by email after the event, so you will get a full copy of the slides by email for those of you registered. And that we encourage you to use the chat function for any questions. There will be some time for chat questions during the end. Yeah, and as I say, we'll aim to close by 10:15. This webinar is being hosted jointly by the Kuehne Climate Center and GIZ, the German Development Corporation, who have together created the Greener Reefer Transistion Alliance, which you'll also hear about later on. So if we move towards the goals of the webinar, the purpose here is to set the stage a little bit to help you understand the opportunity of this Greener Reefer transition. We will be presenting the white paper that has been prepared, and you'll be learning about the technical demonstration, which is planned to show how we can make this transition to R290 a natural sustainable cooling solution. One of the aspects of current refrigerants is that they have these forever chemicals on board. So we'll actually help you understand a little bit more about these PFAS and TFAS, what they are and their impacts and what can be done about that. And we're going to delve into a little bit more kind of the solutions, how we can take this forward, and how we can do that in partnership with other members of the Greener Reefer Transition Alliance. So that sets the stage. So I would now like to pass the floor over to Kirsten Orschulok from the German Development Corporation, who worked with us in preparing the white paper on the Greener Reefers, which was published just a few weeks ago. She'll introduce the paper and also explain more about the technical demonstration that they're preparing to show how these refrigerants can be used in international maritime transport in the real world. Kirsten, you have the floor.
Thank you very much, Mark, for the introduction, and also welcome from my side for this webinar. This is also one of the first ones which we are doing. We will, over the duration of the next months, we will also see regarding the different topics which are popping up in the maritime sector, if we are also addressing other topics, and I hope we will see you then again. Also, I would like to thank our special guest today, Daniel de Graaf from the German Environment Agency, to shed a little bit more insights about PFAS, as this is like one of the main discussion which we, as the German Development Corporation organization, are seeing right now. First, let me share with you a little bit what is the political framework and context where reefers are also navigating, but also in general, we as GIZ supporting a lot of partner countries in the Global South to fulfill the Kigali Amendment and also the Montreal Protocol to prohibit or phase out ozone depleting substances, especially refrigerants. So this is like one of the framework settings where refrigerants are regulated on the international level for national states. Another topic, or where also the reefers are included into, is the Paris Agreement. A lot of shipping industry stakeholders committed to support the implementation of the Paris Agreement, which means a decarbonization of, for example, the fleet, a decarbonization of the cold chain, and also decarbonization of maritime freight transport, which also leads into the efforts by the International Maritime Organization. Also there are member states represented, but especially they are focusing on how to improve, how to make maritime transport sustainable, not only from the technological point of view, but also for the seafarer, for example. So in 2023, the IMO passed decarbonization goals, which are tackling not only the fuel, but also, for example, the energy consumption. And there's especially a call for a higher energy efficiency of different parts for the whole shipping industry, in our point of view, also especially for reefers. Reefers, also here, for those who have maybe not yet been in contact with reefer are maritime cooling containers. So every banana you find in the supermarket, every avocado, but also a lot of pharmacy, a lot of luxury makeup, for example, but also lithium batteries needs to be transported in a controlled temperature environment, because like the outside temperature can vary from -degrees to 10 degrees up to 30 degrees. So the perishable goods within the container needs to have a stable temperature. And these containers are called reefers. And the latest regulation we are navigating in is the EU F-gas regulation. This one especially touched upon which HFCs, so these are also ozone hazard refrigerants, are allowed, but also how to move forward on a European level. But also this has an impact on the supply and the request of certain refrigerants, going more into a sustainable, climate friendly, and also from our point of view, natural refrigerant path. And on EU level, that also goes hand in hand with the EU REACH regulation, where we hear later more about it. So from all these regulations, which are already entered into force, the reefers are part and have to take over some of the aspects into their production. The good thing about natural refrigerants in the reefer is there are already international standards existing, actually since 2019, how to deal with, for example, flammable refrigerants, because the new technology, the new generation of refrigerants for reefers has this aspect that there is a potential to be flammable. Currently, as natural refrigerants, which are discussed, CO2, where already a product is on the market, we know from different manufacturer, they're also working on this like natural solution. And there is propane. So propane is also called R290. And so R290 is from different aspects already on benefit, because it has very excellent thermodynamic properties. So it means also that the energy consumption is very low in comparison to CO2, for example. There are some risks, as I shared, they are flammables, but they are all regulated, and there is guidelines within this international ISO standard. So it's more about how to apply and how to use the ISO standard to make this reefer even more sustainable and usable. We as project have a definition about what is a greener reefer. So I spoke a lot about what is a reefer, but from our point of view, the reefer itself can be more green, more sustainable when it covers not only the refrigerant itself. So as I shared, like we are developing a prototype which is running with propane, so a natural refrigerant, which is also available, which is also kind of cheap in comparison to other refrigerants, but also that the box itself, so the insulation materials, needs to follow certain guidelines from our point of view, so that it's like the production's environmental, cover environmental aspects, for example, but also that there is the chance to recycle the box, because current boxes, due to the foam for the insulation, are almost not possible to recycle them in a very sustainable way. So this is from our project definition. So to produce a greener reefer, which means the cooling unit, but also the box, which does not contain any F gases or PFAS. And so we had a deep dive into the white paper to also understand what are the technological aspects to this. And so this project which I'm leading, we are financed by the German Ministry for the Environment, and we are running until right now, April 2026. It's a small project. And we have also in the Global South, we are collaborating, for example, with Costa Rica and South Africa to make them aware about what does it mean with flammable refrigerants in the ports or in the terminals. But here in this webinar, we are focusing now on the technological part of it, and this is the prototype development, which we covered some aspects, and we did a lot of research in this white paper. So the white paper is also online available. We had a lot of collaboration with it. We got input, for example, from Thermo King, who's also our prototype partner for the development. We worked together with the Wageningen industry, but we also got a lot of input from different stakeholders from the shipping industry. One point is that 96%, so almost all reefers running right now or are used globally using a highly climate damaging refrigerant. So it has a global warming potential for those who are working like more in a climate area of 1,560 in comparison to CO2. So maybe later in the question and answer section, we can go a little bit deeper into it, but this is like right now the fact. What is also a fact due to rough handling, for example, there are leakages. So from these reefers who have also like a 15 years lifespan, there are not so many data available, or also when it comes to monitoring, like there's also a question who monitors like the leakage of these refrigerants. There are a lot of unknown areas. But even to avoid these unknown areas, the best would be to move to natural refrigerants who have no climate and no ozone hazard impacts. So we were lucky in our white paper to have Otto Schacht on board, who is also part now of the Kuehne Climate Center, and he's the former head of the global sea freight section from Kuehne Nagel. So he brought in a very long experience regarding logistics, regarding maritime freight transport, but also regarding reefers. And his assessment was actually that right now, also regarding the political framework, what I showed, the shipping industry needs to act, needs to go into the sustainable way, and also there needs to be a common approach, and maybe even bold action is necessary. As I said, like the current new generation of refrigerants are flammable. So there will be a change within the shipping industry. There will be a change for seafarers regarding security measures, regarding trainings. So the role of reefers, as I shared already a little bit, they have mostly the current fleet, mostly a high global warming potential, and there is leak of this refrigerant. There is a global annual growth rate of 8%, which means that the amount of reefers running with refrigerants globally around the world is growing. It will not be less. There will be no lesser demand. There will be no lesser demand of the transport of lithium batteries. There will be no lesser demand of the transport of bananas. There will be no lesser demand of any perishable goods. So we see this market is growing, which also means that there's a potential for R290, so for propane, but also there is a risk that PFAS, the widespread of PFAS is growing more, because this is part of one other refrigerant of the new generation, which Daniel will also shed a little bit more light onto it. Bear with me with the slides. No. So we did do an assessment, and this is like kind of the gist. We compared like the R134A is like the one which is 96% of the market dominated with this refrigerant. We compared then to the new generation of refrigerant, which is discussed within the shipping industry. The name is R1234YF. Then we have propane, R290, and we have CO2, which is also already on the market. So the last two are natural refrigerants. The first two are synthetic refrigerants. So they need to be industrial produced. They are not available easily. So there's also kind of a commercial interest behind them. So there is the first point is for those who are working in the area, I think quite interesting regarding the energy efficiency and the coefficient of performance. This is like how the refrigerant is performing as within a cooling appliance. The next one is the global warming potential. So this is more regarding for those who are working in climate, quite interesting. I shared also the number based on the latest IPCC assessment report. The next assessment is the costs. So the first two, as I shared, they are synthetic produced. which means especially in the European market. So we have numbers from the European Environmental Agency. They do a survey every quarter of a year and publish the numbers. The costs are increasing more and more and more regarding especially the synthetic produced ones. The end of life is also, there needs to be certain technology things in place for this destruction of these synthetic produced refrigerants, and not every country has this. So as I shared in the beginning, we are working with countries in the global south, and it's a huge effort for these countries to set up this end of life destruction plant. And also reefers who have like kind of a second life. So after years being used in the being on ships, they are then sold to different markets. And mostly this is also in the global south. So which means these reefers who are like run for 15 years on a ship are then mostly stationary, for example, in the global south, where these countries mostly have not the technology possibilities to destroy the climate and ozone hazardous refrigerants. So it's quite an issue there, but today we are focusing on the prototype and the R290 and what we found out regarding the in our white paper. The other points regarding service and serviceability for CO2, as this is a high pressure refrigerant, the technicians need a lot of additional knowledge to maintain CO2 reefers in comparison to the other three, which covers also the next point. Then regarding the flammability, the two of the new generation are flammable. So their CO2 has a benefit of it. The point is actually, and this is maybe also what Danny will cover on, is the toxicity of side products from R1234YF, which is also hazardous for human beings. So in our summary is this actually based on this boxes, R290 is the best option for the shipping industry, as it covers a lot of not only the cost aspects, the commercial aspects, but also environmental aspects. So like a snapshot of our results. So we did do in our paper over 50 different scenarios, like thinking about which of the different political setups I shared in the beginning are followed by the different stakeholders. So they're like national states, they're the shipping industry, they're the manufacturers, etc. So we try to cover all of the different options. The time frame was until 1950, so this is like also a little bit aligned with the Paris Agreement, because a lot of the states should decarbonize until 1950. And we assumed different options regarding the uptake of R1234YF, because we know there are already a lot of the manufacturers have a product in the market, at least one manufacturer, or others are working on it, because this refrigerant is also used, for example, in cars as a refrigerant. There's not yet a prototype or a product in the market with R290, but we are assuming it will come. Our database for this was also thanks to the Wageningen University, that they gave us access to this. So we had a good understanding about what is the current share of which refrigerant is when and how used, and how many certified reefers by the ATO database are in use, and also then worked around this 15 years of lifespan, for example. From our point of view, there are direct emissions. So that's the leakage of the refrigerant. As I shared, some of them has like a very, very high global warming potential. But we are also covered regarding the indirect emissions, like the energy consumptions during the voyage of the reefer. As we did not get a lot of detailed data from different stakeholders, we were relied on literature research, but we are very open to have a second edition of our mitigation potential if we would be able to have this direct data, like real life data, absolutely. But based on our analysis is, for example, just that these reefers are existing in 2018, running around, rough handling in different harbors, etc. just because there is leakage, 3.74 million tons of CO2 equivalent were just released into the atmosphere, just because they were there. The second, on the right side, you see, like, especially the graph below, this is an assumption when it comes to PFAS. And the assumption, so you see like the gray pillars, and this is like the growing of PFAS over the years, especially because the green one would be the uptake of R1234YF as refrigerant. The blue one, which is like dropping so heavily, is R134A, so like this one who is currently dominating the market, because due to the EU F-gas regulation and other regulation and the high global warming potential, the industry needs to phase out these containers. But more details you will find in the white paper. And there again, thanks to all the contributors. So we went into different scenario analysis and assumed also the energy efficiency gains, especially for R290, but also in general, that in general reefers will improve over the years as the manufacturers, of course, try to improve also their own products. So we had like a best case scenario where at least 50% of the market would use R290, where the worst case scenario, where there's a non-compliance with some regulations, and the difference is actually 171.8 megaton CO2 equivalent by 2050, which is like an equivalent of 40 coal power plants annually. So the key mitigation pathways, like when it comes to like the number crunching, is that the switch to natural refrigerants is like a no-brainer, because it has like no global warming potential, is not ozone hazardous, it has no environmental negative impact, it's aligned with the Paris Agreement and the IMO greenhouse gas reduction targets, and also it prevents the TFAS, where we'll learn later a bit more about. So what are the strategies to scaling up the R290 adoption? I will highlight here just a few, but in the paper you can have a deep dive into our recommendations. So one is, for example, the technology, so that it's possible to have the prototype. This is what I'm showing in a second, where we are there with the prototype development, to demonstrate that R290 is market ready. Then also when it comes to regulatory and policies, I think that we will learn a little bit more from Daniel regarding on the EU level, what's currently the discussions. We see also other options. For example, tax benefits would be an option for supporting natural refrigerants. For market and financing is always the key, that it's better to work slow but as a group in comparison to alone but fast. So that's like what I learned from in my work with some colleagues in the African states. So it needs to have a partnership. It needs to have a common goal, even if it's slow, but then it's more sustainable instead of one front runner. And in our discussion in the last months, we also realized that this discussion about R290, so propane as a refrigerant, it's not new for a lot of the manufacturers. So we are not alone, but not many speaking about it. And when it comes,
Kirsten, you have about 2 minutes left.
perfect. And so when it comes to capacity building, it needs trainings of the technicians in the terminals, and there we as GIZ already have a very good network with different training centers in the Global South. Are happy to collaborating also even with more partners to expand this knowledge and the training, so that also the maintenance is more efficient and safe for the people. So for the prototype, the R290 prototype, we are working together with Thermo King. It's one of the 4 big producers globally, and the Universidad Politécnica de Valencia. We are working there especially for the operating mode risk assessment. So this is the step which is described within the ISO standard to show that the product is safe. That's like, it's the common standard. There is always some recommendation what can be done, but in the end, it's about to have a product which is safe for the handling, for the seafarer, for the captain, and also for the logistic workers in the port. Parallel, we are working on an eco-label process for Greener Reefers, which includes also an energy benchmarking. So what I said regarding energy consumption should be lower. Like, no consumption of energy is already climate protective. But of course, a reefer needs some energy. So therefore, we try to have it as low as possible. And we are also developing a safety guidance for ports for handling flammable refrigerants. I shared this in the beginning. Based on our discussion, this seems to be right now quite a blind spot by a lot of the stakeholders, or maybe it's not within the mandate. So now it goes a little bit technical regarding the reefer itself. So as I shared, we're working with Thermo King. We are using their container fresh frozen product as a baseline, like what is the current energy consumption there. And the R290 prototype will have 10% less energy consumption. We are, as I said, will follow the OMRA process, and also we mentioned some risk because it's a prototype development. So there are like some components, as the maritime environment is very hazardous also to metal, for example, with the salty water. We are working on that this prototype is as close as possible for be launched on the market. But of course, there are risks that some components are not available. But in general, we are working quite intensively on this one. So when it comes, and we will launch the prototype into a field test to demonstrate the minus 10% by next year, March, with the shipping line together. So what is driving the sustainability? So it's like the compliance with international frameworks, especially the IMO decarbonization strategy. It's the EU regulations, which some of them have impact on the technology itself, some of the service provision, for example, in the harbors, and some also of the provision of the refrigerants. And which, like, if there's a limitation, mostly the price will go up. So it's also a point regarding, from our point of view, regarding R290. It would be a bad investment to go down a path where you, as a owner of a container, for example, will face higher costs because different refrigerants, which are synthetically produced, and limitation will be more expensive. So this is like the commercial aspect. The other one is the environmental aspect. There will be regulations coming. We don't know yet in which form, but we will learn more about it by Daniel. And the new generation are flammable. So either way, there needs to be a security, safety procedure in place. And the best is, of course, to develop this together between the manufacturers, the shipping lines, the terminals, the seafarer organizations, to have the best product as possible. As I said, like, it's better to walk slow as together than alone or lonely and fast. This is my last words from the presentation. Thank you very much to join me on this quite rush through the white paper. I know that it's already shared the link, and also happy, like, afterwards or in the question and answer session, to answer more details. Thank you very much.
Thanks, Kirsten. Great overview, all the different aspects of these questions and possible solutions. And I would really encourage anyone who wants to dig more into the details and the numbers behind the analysis to have a look into the white paper, which has been shared in the chat. And of course, we will also circulate that link with the email with the presentations to everyone after the webinar. I see a couple of questions coming in, but Kirsten will look at those during the rest of the presentation, and we can come back to the questions at the end of the webinar. You will have heard about these PFAS, these forever chemicals, that are one of the impacts of current refrigeration of maritime containers. This is a very hot topic at the moment, but quite a complex topic. So we're really delighted to have with us today Dr. Daniel de Graaf from the German Environment Agency. Daniel has a PhD from the Max Planck Institute in Berlin. And since 2008, he's been working with the Environment Agency on these questions of replacing hydrofluorocarbons in air conditioning. and he's going to give us an introduction to exactly understand what these chemicals are and why they're important. So Daniel, thank you for joining us. You have the floor.
Thank you very much, Mark, for the kind introduction. And yeah, let's have a deep dive into the topic of refrigerants and PFAS and what they do to our health and how the EU is going to regulate these compounds. So first of all, just a few words about the German Environment Agency. Our mission is for the people and the environment. So by protecting the environment, it's not just about the environment, but also the people living in it and their health. That's our mission. And our tasks are several ones. So like research and data collection, gathering data from the environment, media, air, water, soil, about the climate and about public health. We do policy advices towards the ministries in Germany, especially the Ministry for the Environment. We implement environmental laws, we enforce them, including CO2 trading. We reach out to the public, we inform the general public, we answer questions from the media. And we are a kind of early detection organ for new environmental issues coming up. We are about 1,800 people working in different locations. Our headquarters located in Dessau-Rosslau, which is close to Berlin. I'm talking to you from Berlin today. And yeah, of course, we have a lot of international corporations. For example, so that's what my work is busy with is the Montreal Protocol community, for example, but other organizations such as the World Health Organization, for example, as well. So what are PFAS? What is TFA? So PFAS is an abbreviation, and that stands for per and polyfluorinated alkyl substances. This comprises about 10,000 chemicals. And they're produced from the chemical industry and used in waterproof fabrics, for example, in non-stick cookware, in pesticides, in human medicines, but also, and that's the main emission of PFAS, it's refrigerants. Many of these PFAS are persistent. That means they do not degrade further in the environment and accumulate there. And that is why they are also called forever chemicals. And very common examples are PFOS and PFOA. PFOS stands for polyfluorinated octane sulfonate acid. For example, that's the one here on the left-hand side, this graph. And you see, so that the dark dots, these are carbon atoms, and they are attached to fluorine, fully attached to fluorine. That's why they are perfluorinated, and they have, sometimes they do have groups, like here, this sulfonate group. And PFOS is not a refrigerant, as you may know. It's used a lot in surface treatment of metals, for example. If you want to put lacquers on it, you first pacify them, and you put PFOS on that lacquer sticks to the metal. Yeah, another important candidate of PFAS is TFA. TFA stands for trifluoroacetic acid. It's a basic chemical directly produced for several purposes, but it's also a breakdown product of certain substances, especially refrigerants, such as the HFO refrigerants, namely R1234YF. So this is today, well, I would say the main source of TFA in the environment. It's also a persistent compound and also adds to the PFAS contamination, especially in water and soil, and as I said, it's a persistent substance, and so it accumulates there and poses risks to the ecosystem and to human health. I didn't mention PFAS and PFOA. They've already been banned because they have health impacts, and there is now a restriction proposal for all the PFAS substances in the EU under the REACH regulation. REACH stands for Registration, Evaluation, Assessment, Restriction of Chemicals. And this proposal has been handed in 2 years ago by 5 member states: Denmark, Netherlands, Norway, Sweden, and Germany. And as I said, it addresses all the PFAS substances because of their toxicity and the persistence. And yeah, example I've already given as well, it's TFA. And I found in the proposal a certain sentence which I want to read out to you, which puts it very, or puts it in a nutshell why these substances should be restricted. So some scientists argue that the planetary boundaries for PFAS have already been exceeded, and human biomonitoring studies show that the cocktail of PFAS, so the many PFAS that are out there, to which parts of the general population are exposed to through different sources, such as food, drinking water, products, etc., already may result in health risks. So we are already beyond the point where we can accept these substances to accumulate in the environment. So there's a certain definition which is the same as the OECD defined PFAS, and that includes, and that's the important part for you, all fluorinated refrigerants, except for some of them, R23, for example, and R32 are not covered by this definition and therefore not restricted. As soon as the restriction, the prohibition comes into force, there is 18 months where these where new products with PFAS are still allowed, and after that you're no longer allowed to put these products on the market in the European Union, except for some applications and appliances such as very low temperature cooling, laboratory testing and measuring appliances, refrigerated centrifuge, and mobile AC and transport refrigeration. So this would apply also to reefers. So after this proposal comes into force, you have a limit of 6.5 years. We can still put these products on the market. After that, completely forbidden. You still can refill the existing plants and appliances. That's allowed for another 30.5 years after the entry into force. So having a closer look at PFAS and TFA, you find them globally all over the planet, even in remote areas like the Arctic, and you find them especially in the soil and the water. Since it's persistent, it doesn't go away. It moves into the groundwaters, and with that also into the drinking water. You can find them in sediments. It enters the food chain. You find PFAS and TFA in plants and animals. And since it's in the food chain, it's also in humans, because we eat plants and animals. And therefore, you also find PFAS in humans, in urine, in the blood. And yeah, I think the most prominent intake route is the drinking water and the food, of course, but it's mainly the drinking water. And the problem with this is you cannot remove TFA from the water resources. That's not possible. Well, there's one method. It's called reverse osmosis, but it's very energy intensive. You need a lot of energy to run it. It's costly, and you lose 50% of the water you treat. So an enormous problem. So this is not applicable to grand scale drinking water preparation. So here some refrigerants which are used today. I focused on refrigerants with low or lower GWPs, except for the two ones actually. So this is R134. We heard it before from the talk of Kirsten. 96% of the reefers run on this refrigerant. And here are also the candidates which are discussed or already implemented as an alternative, R1234YF. And this one has a TFA formation potential of 100%. That's here in the column on the very right. This means every molecule of this refrigerant breaks down into one molecule of TFA. 100% yield. And I'll show you some graphs later how this will impact TFA emissions in the environment. R134A has not such a high formation TFA formation potential, but since it's one of the most ubiquitous refrigerants, the TFA, the total TFA coming from this refrigerant is also quite high. And of course, natural refrigerants, no TFA formation potential, no problem on this side. We did a study and asked, well, what are the maximum TFA emissions which will occur in Germany if we use the HFO refrigerants more and more? This is already the case in car refrigerants. Kirsten also mentioned that. 50% of the cars, we have close to 100% equipped with air conditioning, and 50% of the cars in Germany, about 48 million, they run with R1234YF as the refrigerant. And this is why you can see it here in this column, that so that's the orange fraction. This is a TFA coming from this new HFO refrigerant already today. And R134A is the other fraction, the blue part. And this is more and more replaced by TFA, by the HFO refrigerant. And you can see this is the most important entry of TFA into the environment. There are other sources, such as pesticides, human medicines, but there it comes rather negligible, and the rest, there's only limited data available. So refrigerants is the most important part. From the fluorochemical industry, they like to refer to studies. They say, well, TFA comes from natural sources, like hydrothermal vents, but you can see here, this column is rather non-existent. It's negligible. So TFA persistency, that doesn't sound too scary, but it turned out in recent years that TFA is not only persistent, but it's a toxic. It's a liver toxic and reproductive toxicant. That means the offspring, if you take up too much TFA into your body, then the offspring, your children, have a problem. And this was found out in animal testing. They fed TFA to rabbits, and the offspring, the little bunnies, they showed malformation of the eyes. So it's really an issue we should keep an eye, and that's what authorities are doing. So there's a proposal to reclassify TFA in the regulation, in the CLP regulation. CLP stands for Classification, Labeling, and Packaging of Chemicals. So they want to newly classified under 1B, that's presumed human reproductive toxicant. And I already told you that we find TFA today in drinking water, and that's the case for a lot of wells in the European Union. And the dotted line here, the red dotted line, is a limit put up in the Drinking Water Directive of the Union. It says, well, you can go up to this limit, and then the drinking water well needs to be goes down, because the contamination with PFAS, so it's not only TFA, it's all the PFAS put together, and this is not allowed to exceed 500 nanograms per liter, and after that, this well is gone for preparing drinking water. And as you can see, this applies for a lot of wells in the European Union. So it's already a problem today. And not only the drinking water, you can find it in very different media, in plants, in food, basically everywhere. So this is from a study by Hans Arp and colleagues, and they looked at concentrations of TFA before 2010. This is the green bars, that's the maximum values they found. The average values are given in these green dots or circles. And then they looked at post-2010 values, and you can see that whatever media you name, average and maximum values are increasing. A few exemptions, but all in all, we have rising TFA concentrations everywhere. And so there's another quote which I took from this study. And so the colleagues, these researchers say that that there are obvious places to start to get rid of the growing TFA concentrations, TFA load in the environment, and that's getting rid of the direct production, and they say more importantly of TFA precursors such as the HFO refrigerants. So they actually appeal to us, to the authorities, to the industry, please try to avoid using HFO refrigerants such as R1234YF. So just a few more words regarding the restriction proposal. It's not, it didn't come into force yet. So we had a public consultation in 2023. And now the statements of the ECHA committees are prepared. That's the Risk Assessment Committee and the Socio-Economic Assessment Committee. And upon these statements, the EU will take a decision. It was anticipated for 2025. Now we have 2025. They now think, well, that's internal assumption from the EU Commission, that entry into force will come in 2028. So some years from now. And what concerns the reefer industry, this plus 6.5 years, so 2035 there will be, if the proposal will be decided on positively, PFAS will be restricted in the reefer industry.
You have 2 minutes left, Daniel.
Thank you. That's, I think, 2 slides. So to sum this up, TFA is a persistent liver and reproductive toxicant, which accumulates in the environment, and not only that, also in animals, in plants, in human beings. It's everywhere. Major emission sources, as I told you, are refrigerants and propellants, such as the ones used in the reefer industry, R134A and R1234YF. The PFAS restriction would prohibit most of the fluorinated refrigerants, and we could completely avoid the the emissions of TFA into the environment by using environment-friendly refrigerants such as R290. And yeah, this calls for action to transition to these safer refrigerants such as R290 or R744 CO2, which pose no risk to the environment and to human health, except for their fluorinated counterparts. This calls for stronger regulation, such as the PFAS ban. We should raise awareness, encourage stakeholders to promote sustainable practices, and of course to join movements such as the Greener Reefer Transistion Alliance for cleaner shipping. Thank you very much for your attention.
But thanks, Daniel. That was great to get a deeper insights into this. One question that came up in the chat was that when will the EU PFAS restriction preparation take place? I think you said that is planned for 2028, but could be later, right?
Yeah, so 2028 is assumed to be the entry into force. And when it comes to reefer, which is part of transport refrigeration, you have to add 6.5 years for that's the transition limit, so to say. And so we will be in year 3035 when this will come, or this will restrict also applications in reefers.
Okay, thank you. Thank you for the clarification. Okay, so Daniel mentioned at the end the possibility to join initiatives to work on this transition to natural refrigerants. And so it's my pleasure now to give the floor to Lydia Ondraczek, who's going to explain a little bit more about how we're working with our partners in the Greener Reefer Transistion Alliance, in case any of you are interested to participate more in this work. Lydia, you have the floor.
Thank you, Mark, and thank you, Daniel, for already making the call to join our movement. Highly appreciate ambassadors that talk about us and our work. So I hope everybody can hear me well, and I will briefly give you an overview what is the Greener Reefer Transition Alliance about. And if there are questions, please reach out afterwards. Yes, so the Greener Reefer Transition Alliance, as the name already implies, we are pioneers and we want to revolutionize the refrigerated shipping. Yeah, also to be part of a sustainable future. And we really look forward to do that together and in a collaborative manner. So the Alliance was created and initiated, of course, a bit before COP, but launched during COP29. And here you see our former colleague, Philipp Denzinger and Otto Schacht, who made the first call during a side event at COP. And Kuehne Foundation, Kuehne Climate Center is a strong partner already with us. And now we are reaching out for more members and stakeholders. And we focus on promoting environmentally friendly, sustainable and climate-friendly alternatives for the reefer container industry in the maritime sector. And as I said, we want to bring together industry, of course, front runners and innovators, but we also look for stakeholders that come from the public sector and private stakeholders. So maybe Uber wants to join our initiative. Daniel, let's have a deeper look into it. We highly appreciate also organizations from that sector, because we believe if we spread the word in many different rooms, then this movement becomes a strong one. And and we want to establish an environment for adapting that the Greener Reefer solution can actually grow into the field. And so let me see if I can move for the next slide. And Kirsten gave a really good overview of what the project is about when we talk about Greener Reefer. Daniel gave a very deep insight about the PFAS problem, and the Alliance tries to put all those topics together because we look forward to reduce direct carbon emissions by developing this Greener Reefer solution and spreading the word. And we also want to reduce the indirect carbon emissions by, as Kirsten already said, looking into the energy efficiency and material aspects. And we only can do that together. So we need manufacturers, we need shipping lines, we need consumers, we need cargo owners, we need ports, we need trained staff and technicians. So we need to have a really good collaboration that this new technology can actually come into force. And it is really crucial to facilitate knowledge and information sharing. There is a lot happening at the moment in different rooms. And so we try to bring this together and actually make it understandable and digestible and applicable for our stakeholders. And by the demonstration of the technical and the commercial viability of the Greener Reefer, we create also a blueprint, a touchable blueprint, something that you really can see, and we want to test and we want to run it and we want to showcase that it is really working. So we also look for partners who support us in this area. And advocacy and education is always something necessary. So we also want to reach out to the younger generation, but also to ambassadors, as I already said, who gives us a hand, who acts as wing and man and wing woman to talk about us and our activities in rooms where we have no access yet. So this alliance is a bundled force group with open hearts and open soul to really move them forward. And we are really looking for more to join. At the moment, as I said, it is GIZ, our project, the Kuehne Climate Center, Wageningen University. We are already in talking conditions with other potential partners and hope to materialize in the next weeks and announce who will join. But please feel free and hopefully invited to engage with us and look into the opportunity and possibility to be part of a movement that makes a real change and difference. And I leave it here, Mark. So we give our audience a chance to ask questions and maybe trigger a discussion. And we will have more webinars to come up, and there will be more opportunity to talk. And if you have interest in the Alliance, please reach out to us. Happy to engage and discuss. Over to you, Mark.
Thank you very much, Lydia. Thank you. Hopefully, amongst the quite considerable number of people we've got here today, there'll be some organizations or people that are interested in joining us on this, on guiding and accelerating this transition. There was a couple of questions in the chat for Kirsten, I think. Kirsten, can you address those two questions about the white paper?
Mm-hmm. Absolutely. So one is maybe I will start with the second one first from Sepova regarding that it's a no-brainer to switch to national refrigerants. So what is the main thing stopping companies change your experience? So there are like, one is its experience. So especially propane is a flammable refrigerant, so it's something new. And especially in the shipping industry, it's an industry which is like established for hundreds of years. So everything which is new and innovation needs to be very thoroughly tested. And so it's very slow. And the other one, which is maybe also one point regarding experience in comparison to stationary cooling appliances, where we as GIZ have a positive experience with R290, also for example heat pumps. So it's not only cooling, propane is also used for warming, especially in Germany. Heat pumps are running with R290 all over in Germany, and it's not a problem. The difference is, as with this stationary appliances in comparison to the reefer, which is like moving around, it's the number of people who have access to it. So the human error is always a big question. It's similar like with cars. There's like always like the technology can work as well as possible, but if the driver make a mistake, then there is an issue. It's the same also with this technology, that even if the design is as safe as possible, humans can create an issue. And so there's like a lot of question marks by the industry as it's new. There's not yet experience to it. And it's, especially the shipping industry is a quite an industry which wants to be very certain that it works out. So we also have this similar discussion when it comes to alternative fuels, for example, with hydrogen. So that's my assumptions why there is maybe a low transition going to natural refrigerants, but CO2 is already in market. R290, we know from different manufacturers they're working on it, and we are very public about the collaboration with Thermo King on this R290 prototype, because we think now is the right time to introduce this one. The second question, also thank you very much. So it was a little bit of a description, so I will read it out loud that we are all on the same page. So vessels calling South America countries to transport the reefers are not new, and the banana are stuffed as hot cargo reaching 30 degrees. So considering those variables, we are going to face on board of the vessels that the inside cargo holds temperatures reach to 50 to 60 degrees and ventilation extractor aren't the best. So it's bananas are best transported by 14 degrees. But if the reefer, for example, in Costa Rica is standing in the sun, it's a metal box, it builds up heat. And then to put in bananas, who is like, I learned from the Wageningen University, it's like a breathable good. So it's like at a certain point, it will start the ripening process because it's the same as apples, etc. So you need to have a controlled temperature. So if the box is already hot and then you bring in the bananas, the engine needs to run on high speed to lower the temperature, and some of the reefers, the ventilation and extractors aren't the best. Totally right. To reach the set point for the bananas, the reefer machinery must work on full cooling, so the heat interchange increase, producing more heat inside the cargo holds. Low electrical insulation in the main components. Sorry, it's my chat jumped. Low electrical insulation in the main components can cause a short circuit. Did you take into consideration described issues for the benefits and manage of R290? Yes, that's the short answer. And in long, it's actually explained by the ISO standard from 2019 to have like a certain standard of safety measures in place. So especially for the electrical wires, etc., there are, it's called ATEX standard. So it's like that these, like the fans and also the electrical circuits, etc., does not ignite a spark, which is especially for R290 important. So we bring in also all this experience which we have with a stationary R290 appliance into this process. These components are available, but like just in small numbers, as I said, like the R290 or flammable refrigerants are something new. It's like a new generation. So the components producers are also right now in the transformation to offer these components. And yes, we absolutely take this into account because our reefer will be as safe as possible.
Thanks, Kirsten. There was another two questions, I think maybe more for Daniel, which is, where is R1234YF used? And in particular, and I think many of us will have this question, there was that incredible spike when you showed the concentrations of PFAS in European drinking water, that incredible spike in Upper Austria. Was there any insights into what was causing that incredible peak, Daniel?
So the problem here is that, as I showed you before in this one graph, that you have different sources of TFA emissions. It's not only the refrigerants, it's the biggest or the sector where the most TFA emissions come from, but they're quite scattered. And on the other side, you have TFA as a basic chemical, and that's produced in certain industrial sites. For example, in Germany, it's on the banks of the river Neckar. And there has been an accident, and TFA was released in quite large quantities into the river. And this is why still today. I think this accident took place about 6 years ago, and they had to close down several drinking water wells in this region. So that's the region of Heidelberg. You may know this town in Germany, Baden-Württemberg, southwestern part of Germany. And so you have both. You have this quite scattered emissions, which come from the refrigerants because the cars run everywhere in Germany, basically. And so you can't pin down certain locations. And on the other hand, you have emissions from this basic chemical production or from transport, for example, on the road accidents. And why a certain well is shows such a heavy contamination that's not clear in all the details. So sometimes you have wells which are quite close together. One shows no contamination, no TFA detectable, and the other one, which is just a few kilometers away, heavy contamination. So where this stems from is in most of the cases not clear.
Okay, thank you. We're coming to the end of the time now. There's another question that I'd like to invite Kirsten to answer. You mentioned that you're working with some countries in the global south, Costa Rica and I think South Africa. Can you explain briefly how I mean GIZ is working on international cooperation, how you're engaging with them on this question, please?
Yeah, thank you very much for the question regarding how the project Greener Reefers, implemented by GIZ, is collaborating with South Africa and Costa Rica as partner countries. I will share a little bit about Costa Rica or our general approach, as also Lydia is the focal point for South Africa. So if you have any questions regarding or detailed question regarding the activities in South Africa, please reach out to her. The main focus is that we are supporting the national ozone units, which are like the national representatives to the Montreal Protocol for the negotiations. So there's the negotiations about which refrigerants are allowed into a country, what are the phase out, what are the phase down options, and they are mostly based into the Ministry for the Environment. So with them together, we develop a plan how to mostly train the technicians to maintain cooling appliances with natural refrigerants, because this knowledge is not yet widespread or like the standard in a lot of the training centers. So in Costa Rica, we are also especially collaborating with the Monte, for example, to create like a better environment also for women who are going into like the training centers or schools. It's actually like a different education system than here in Germany. It's a little bit like vocational training to increase the attractiveness of the job for technicians in the refrigerant and AC sector. And then also to go, for example, to the terminal to be part of like the crew who is maintaining the reefers. So that's a collaboration in Costa Rica, especially with the Montes. So we are reaching out also to the private sector to increase the numbers of technicians, because this technology, the same we experience in Europe or also in Germany, it's a technology, the need for cooling and heating is increasing globally. So if you are thinking about to switch jobs, becoming a refrigerant technician is a way forward. It's a future safe, also with the global warming, unfortunately. And in South Africa, we are focusing there to work together with 2 training centers, also to expand their offer for the industry, but also for technicians to be more specialized into reefer technicians, to become reefer technicians, so that the other side of the world is ready for this. And we will work also with the ports and the terminals in both countries to understand what are their needs if like flammable refrigerants, reefers with flammable refrigerants are arriving in the ports, how to maintain them. So we are doing like the young generation, but also the people on the job, targeting with different capacity and skill enhancement components.
Thanks, Kirsten. So we're coming to the end of the time now. Hopefully this webinar has kind of raised your attention and understanding of the issues around the current refrigerants that are being used, and this incredible opportunity to transition now to alternatives that that are cheaper, that have much lower global warming potential and don't contain these forever chemicals. And with a good box design could also actually reduce the energy consumption, which as a result of recent IMO decisions is going to be even more in the focus for container ships. So so hope that's, I'd like to thank our speakers, particularly Daniel de Graaf, for taking the time to join us and give us his insights into the technical aspects of the chemical pollution. As I said, we'll be circulating the material and the links that we've shared in an email to all the registered participants. We also shared the link in the chat. Please follow the work of the Greener Reefer Alliance on LinkedIn. That's an easy way for you to keep up to date. And if you're interested in joining the Alliance and participating more actively in our meetings, in our site visits, in our webinars, in our workshops, please reach out to Lydia for more information. So thank you again for joining. And that's the end of the webinar. Thank you. Bye-bye.